Hello viewers, welcome to my channel Dattu's Class. This is a video tutorial series on Computer Networks Laboratory using NCTU-NS. The first experiment is simulate a 3-node point-to-point network with a duplex link between them. Set the queue size, vary the bandwidth, and find the number of packets dropped. If you observe the question, there are 3 parts. In the first part, we need to design the topology of the network. That is, we should have 3 nodes and the connection between these nodes should be done using a point-to-point link. For the sake of the connection, we are using star topology, and the aggregator unit is a hub. In the second step, or second part of the question has network elements which affects the performance of the system. That is, we need to set the queue size, which is a part associated with the host machine, and vary the bandwidth. Here bandwidth is associated with the link or with the hub. And finally, we need to find the performance of the network in terms of number of packet dropped. In order to run NCTU-NS, we need to open the terminal, and in the terminal we need to open 3 tabs. In each tab we need to launch 3 processes, and the sequence is very important. First we need to run dispatcher. In the second tab we need to run coordinator. In the third tab we need to run NCTU-NS client. So running these processes in this sequence will launch NCTU-NS GUI, and this is the tool where we need to run our experiment and we need to analyze the network performance. So as per the question, so first I will select this host. Since there are 3 nodes, so node 1, node 2 and node 3. So connection between them was a star, so I will select this hub and click here. As the connection was point-to-point full duplex, I will click this button, point-to-point link. I will connect from node 1 to node 4, node 1 to node 4, node 3 to node 4. I will make annotation to these systems. We will give it a name as sender 1, this one sender 2, and for this one a receiver. And this is hub. So this is the topology what was asked in the question. Next we need to move to the second stage of the experiment, that is, we need to edit the node and the link property. Before that we need to save the topology by a file name. So for this I will give it as exp test1. One thing is important, don't give the extension. By default it will be taking it as .tpl. Simply give the name and hit the save. So it will ask topology need regenerate IP addresses. So click S, and at each of the interfaces you will get an IP address after saving the file. So here this is important. IP of the destination, that is 1.0.1.3. so click sender 1 and click the add button. So here I can change the simulation type, so I will be setting it as 20 seconds. The command is stg-u 1024 100 1.0.1.3. See here, S represents source and TG -u represents we are operating in an UDP mode and the packet size is 1024, and this 100 represents the port number on which the communication is happening. Finally, this is the IP address of the receiver to which this sender is transmitting the packet. The same procedure, click on OK and click the node editor button. A window will be opening up. Here, double click on FIFO. So here I can vary the queue length. So I will be setting it as 25 for sender 1 and click on MAC button. So a window will be opening up. So click on log packet statistics. As per the question, I need to measure the number of drop packet. Click OK. So see here, the link is full duplex and the link is point to point, and the mode is full duplex. Click on OK. Again click on OK. OK. This is the setting what we have done for sender 1. The same procedure needed to be repeated on sender 2. Press on add, change the simulation time to 20 and write the command as stg space -u space 1024, port number is 100 and destination IP address 1.0.1.3. So click on OK. Again go to node editor and click on FIFO. So queue length is 25. Click on OK and double click on MAC. So click on log packet statistics and number of packet dropped. Click on OK. Again click on OK and OK. Finally, we need to do the configuration on the receiver end. Click on add and change the simulation time to 20 seconds and write the command as rtg space -u space -w and file name as log experiment. See here, R specifically represents the receiver, TGU represents it is operating in the UDP mode, -w means writing the log onto these respective files. Click on OK, click on node editor of the receiver and again click on FIFO. Change the packet size to 25, that is queue size. Just click on enter and press OK. So another parameter will be present in the hub. Double click on it and bandwidth is 10. I will be leaving as it is. Okay. So this is all the configuration part we have done. Next we will be moving on to the run mode. As I am operating in the VM, sometimes the mouse capture will be problematic. In that case, click on the right control button so press on R. So again it will ask for saving the topology. Click on S, number of files will be generated, so click on OK. So we are now in the run mode. So go to simulation tab, click here, click on run. So simulation will be running for 20 seconds and the clock will be ticking here. So it will run for 20 seconds. So we need to wait until the simulation engine run for 20 seconds. So we will be pausing the video. Yeah, simulation is progressing and it is completed 17 seconds. See, after 20 seconds, this scroller will be moving fastly. Once the simulation is completed, a dialog box will appear like this one. Simulation is done. File transfer are about to begin. Depending on the file size, it may take long time. Please be patient. Hit on OK. So file transfer process will be completed then. So now it is dumping the files. So now we moved on to playback mode. So in the playback mode, hit the play button in order to view the packet transmission between the sender to hub, sender to hub, and finally from hub to the receiver. So playing back. See here, the red line, blue lines are mainly used to represent data transmission. Sometime an into mark will be appearing. It represents the packet drop or collision in the links. So playback mode will be occurring continue for 20 seconds. Playback mode is optional. You can view or simply stop and go for the next step. So see, sometimes there will be an X mark. Do observe that one. That is the thing we need to measure. I will be telling how to analyze the log files as well as how to plot the graphs graphically. So after 20 seconds, there will be no data transfer since I have set the simulation for 20 seconds. So see, simulation has stopped. So just click on stop button. Now we need to analyze the network performance by studying the log files. For studying the log files, there are two ways. First is graphical way, in which we are reading the data from the text file, log files, and plotting them time versus packet loss. Or another, we can directly view the log files, what we have enabled in the network and editor of each of the host, and we can measure what is the maximum packet drop and minimum packet drop or collision throughput, whatever that has been asked in the question. So in our case, it is packet drop. So first I will show you the graphical way of analysis of the network performance. So go to G tools, click it, and click on plot graph. A graph tab will be opening up. So see here, it is time versus value, and we need to give the graph title. So here it is 0 to 4 means basically 5 seconds it is, but we have run our simulation for 20 seconds. So we need to modify the graph settings. Go to general settings. Here give it as time, and graph title as packet drop. So width is 5 seconds. We have run for 20 seconds, so I will be giving it as 20 seconds. Rest of all can be leave as it is, or in this case I will be writing the y label as packet. So click OK. So now the graph will be rearranged. Now we shall fetch the log file so that we can see a plot of time versus packet loss. So click on open. So whatever the experiment name what we have given, and log file will be generated in the same way. So it will be stored in /root/. So here it is our experiment name, exp test1. So search for the folder exp test1. So here it is, exp test1 results. Double click on it. So we have enabled a single log parameters in each of the node, that is n1 to p1. Here n1 is sender, p1 is up, n2 is sender, p1 is up, n3 is receiver, and p1 is up. So first we shall see the sender one's log characteristics. Look here. So 0 to 20, if for each of the second graph plot will be there. So in order to analyze, say at the time 12 second, maximum packet drop of around 240 or 250 packets has been dropped. In order to view accurately, this is the graphical way of viewing. So go to, so minimize sensitiveness and go to roots home. In the roots home, check for the file name what you have given for the experiment. In our case it is experiment test1. So here it is. Double click on it. So now see here, experiment test1 802.3. Basically this is the protocol, wired protocol code will be there. So n1 to p1, click on it. So in our case, after 12 second, maximum packet drop of 248 has happened, and a minimum packet drop of, in this case, search for the minimum value for the packet drop, and it is 15 second 168. So you can quantify in this manner. So maximum is how much? Yeah, it is 248 at second 12. So look through the graph. So at 12 second it is 248, and at 15th second it is about 160. So go for this one, 16 second, 15 seconds, sorry, 168. So this thing you need to write in the results file. So this was the question, and this is the result what I have created, result file. So result one, here I am setting my queue size as 25. I left the bandwidth as it is. So maximum packet drop n1 to p1 was how many packets that has been dropped in our case? It was at second 12 it was 248. So write it as 248 at time period 12. Next, at the time period 15, I was seeing the minimum packet drop, and it was 168. 168. So similar thing you need to do for N2 and P1. So just close this one, and in case of graph, first we shall see the graph, next we shall move to the log files. N2 P1. Maximum packet drop is occurring at second 10, and it is about 240, and minimum is 50, and it was about say 160. So in order to accurately quantify it, again go to this experiment results, N2 and P1, double click on it. So at second 10 it was 242. So write it as maximum packet of 242 at time period of 10 second, and minimum was 15 second, it was 164. So it is 164 at time period 15 seconds. The same way, again we need to look the packet drop between node N3 and P1. Double click on it. So first we shall go for the graph one. So we shall maintain the procedure. Open N3 and P1. So here the maximum packet drop is around second 3 seconds, and it is about 175. What it is? Yeah, maximum packet drop of 178. And see here also 178, and second 12 also 178. So it is not that at a particular second you should get a single value. At a 2-time instance there can be maximum packet drop. In that case we need to write it as maximum packet of 178 has been dropped. 178 has been dropped at second at time 3 and 12 seconds. That's it. 3 and 12 seconds. If you look through the minimum packet drop, we get it as 148. Yeah, see here, 148 is occurring at 2, 18 and 20. So we need to write 148 packet at 2, 18 and 20. So this is the analysis of the experiment. Here it is. Thank you. This is about the first experiment.